is the loop structures. And always the loop structure will slow down the execution of programs. So sometimes we can use vectorized form to do the programming. We can use this as an example. This one can be done easily by the for loop, and the command is something like this. For each value of I, we add the term to the value of S, so we can do the summation test. This is quite similar to the problem I showed earlier. And we use TIC and TOC to read the time used. Also, suppose that we can define a vector. The vector contains from 1 to 10,000. That's 100,000. Suppose there is a vector like this. So what does this mean? 2. It is also a vector. It contains 2 to the power 1, 2 to the power. It is also a vector. And what is this? Something like this. It is also a vector. So the same thing can be done to 3. So we have a vector here, another vector here, which are the terms like this. And we can add all the terms together by the sum function. And in this case, we do not have to use the for loop. We can just do it in a vectorized form. So in this case, we may expect a faster execution. So let's compare them. With for loop, the time required is longer than the one we vectorized for. Nowadays, when Matlab is developed, they concentrate on improving the quality of for loop. So it is much faster than it was before. In the earlier versions, the time difference is very significant, but in this case they are compatible, not very much difference, twice or 3 times difference. So we can use vectorized way to perform computation. In that case, we can avoid the loops, which can speed up computation. Let's consider another control structure, conditional control structure. The structure is something like this. Using the if statement and test whether the condition holds. If it is hold, then this part is executed, and then the program switches to this part and continues and bypass the if statement. If this condition is not satisfied, then the second condition is tested. If it is satisfied, then this part will be executed. If all the cases are not satisfied, this part will be executed. So this is the conditional control structure. I shall explain it with examples later on. And there are some simple forms, simplified form of if statement. If and or if else and. Remember that we have to use and in each control structure. In the for loop, while loop, and also the if statement, we have to use them. So there are some simplified forms of conditional control structures. And this is a block diagram of conditional conditional structures. Here there is an example. To solve the previous example I demonstrated, we can combine the use of if statement and the for statement. So we cannot solve the problem with for statement alone, but with the help of if statement we can solve the problem. And the command is something like this. Suppose s equals to 0, and then we can do the for loop, and we can use a large number here, any number you use, but do not use small numbers. We have to use a large number here. And then, just in the, like in the case of normal for loop, we add the term to s. And then, we check the sum, whether it is greater than 10,000. If it is, then we use the break command. And break command can be used to terminate the last loop statement. It has nothing to do with the if statement. It will terminate the last loop statement. It will treat back and see there is a loop statement, so it will terminate it. And we can finally find the value s and I, which is the required n. And it seems that this kind of statement is not simple as the while statement. So for this kind of problem, we try to use the while statement. And there is a switch structure which is similar to the case in C language. We can have a switch keyword switch, and then there is a variable name. It is a switch expression over another switch expression. And the program is like this. When executed to this point, it will test what is the value of the switch expression. If it is found that the value of it is expression 1, then this group of statements will be executed. And unlike to C language, in Matlab, then once this one is executed, the program will be transferred to this point and carry on working on the program. However, in C, it will be used to execute the following statements. However, then the difference between Matlab and C, Matlab will execute this statement and then go out of the switch statement and continue on working. So this is the one difference. The other one is, once this expression equals to one of the several expressions, then we can group them up with the brackets and as a single condition. And if it is equals to one of them, then this part will be executed. It is slightly different from the C language. In C language, you usually have to use the case expression 2, case expression 3, something like that. In Matlab, you have to group them by brackets. And the other difference between Matlab and C is the keyword here. C code here is default, so we have to use other lines in Matlab. So the statement is different from C, and I have listed several differences. These are the block diagram flow chart of the program, of the switch expression. And there is also a very useful structure which is called the child structure. I don't think there are other substructures in other languages. The execution of this structure is like this. First, the program will try the first group of statements. If there's nothing wrong happen, there's no error happen, then the whole block will be terminated and the program go on to this point and then went on to execute. If there is an error in this